A very good evening once again to all the tech enthusiasts gathered here today. We're excited to kick off the fourth session of the AI Bootcamp Series 2023, focusing on implementing generative AI models in practice. So before we start off our session, I would like to share a few guidelines for this session. Please keep in mind that the Q&A session will happen after the session has concluded. You can direct your questions to the Slido platform in the meantime, and we will share the Slido link shortly to our chat. Delegates, kindly rename yourselves in the format team name, first name underscore last name. You can find your team numbers in the link provided in the chat. Dear representatives of our partner companies, we appreciate it if you could rename yourselves as AI Bootcamp company name. And all participants kindly ensure that you are muted at all times and your videos remain off so as to not disturb the smooth flow of this session. So before we dive into our session, let's express our gratitude to our esteemed partners. IFS, as our official trailblazing partner, has played a pivotal role in making this bootcamp possible. We are also grateful for the expertise and support of our AI expertise partner, Zone 24/7, our mentoring partners, WSO2, 99X, and Nagaro, our industry collaborative partner, Slascom, our ecosystem partners, Virtusa, Trace, and Axeler, our judging partner, LSEG, Surge Global, and Mad Mobile, our venue partner, the IEEE student branch of IIT. We extend our gratitude for their invaluable contribution, making this event possible. Now, before we proceed with the session, let's take a moment to appreciate the significant role played by our official trailblazing partner, IFS. We have a specially curated video to showcase their incredible contributions to the field of artificial intelligence. Let's watch the video now.
IFS is powering big enterprise, big ideas, and big change. With technology that enables companies to innovate and grow. With unparalleled industry depth that provides a way to create value by joining the dots and help companies engage with their customers, empowering their people and use their assets so that they can deliver when it really matters at the moment of service. Touching our lives and improving the way we do business across the world.
From the moment we wake up.
To how we travel.
To the business we do.
And how we care for our world.
IFS is leading the way in empowering thousands of the world's most progressive brands. Let us help you be your best
at the moment of service.
A round of applause for IFS, our official trailblazing partner. Now, to give you a glimpse into the expertise that Zone 24/7 brings to the table, we have specially curated videos for you. Let's watch the videos now and get inspired by the cutting-edge AI innovations from our AI enterprise partner, Zone 24/7.
Zone 24/7, an advanced technology and research center established and headquartered in San Jose, California in 2004, specializing in offering end-to-end technology consulting and engineering services encompassing both hardware and software. Our sound research and development background means that we are constantly developing leading-edge technology solutions ahead of market needs. Our ability to meld hardware and software solutions places us among a handful of companies in the world with the ability to do so.
Zone 24/7 has continued to show phenomenal growth since its establishment, which has pushed us to be a pioneer in the IT industry. We work towards our vision of enhancing the emotional experience of everyone we touch, be it our customers or employees who are part of this great organization.
Our global outreach is empowered by local talent. We are the industry leaders when it comes to hardware and software, catering to an array of industries and providing state-of-the-art products and solutions for global customers. Zone 24/7 is led by a tech-savvy leadership focusing on technology innovation, and our direction is shaped by mentorship and guidance. We are an organization with autonomy and empowerment, which brings creativity and innovation to our day-to-day lives.
We have a diverse range of products and solutions being developed under one roof, bringing in major technologies and diverse tech stacks into our work. We are the industry leaders in a multitude of technology domains, including software engineering, artificial intelligence, machine learning, big data, robotics, embedded systems, and many more. We are also a pioneering leader in software quality assurance and test automation, striving towards making us a center of excellence in software quality assurance. Zone 24/7 has the luxury of a work culture that is collaborative, friendly, caring, and supportive. Both our culture and environment build camaraderie among us.
Our culture has inbuilt learning and development, defining us as a learning organization where knowledge and learning are highly valued. Zone 24/7 is a place where one can learn, grow, and achieve a great career.
We have a mentoring and coaching mechanism to support individual career growth. We follow industry best practices in managing talent and keep a high focus on the potential for growth and personal development.
Your aspirations are important to us. We provide opportunities to create, innovate, and influence our global products and solutions. You will be able to see the results of your work in a global environment and grow in a career aligned with your expectations and potential. Providing opportunities for intellectually demanding and emotionally rewarding work. We are Zone 24/7.
A round of applause for Zone 24/7, our AI enterprise partner. Now let's introduce our distinguished speakers for today's session. Our speakers today bring a wealth of experience and expertise to our discussion. Mr. Nisal Mihiranga, a seasoned data science professional with over 11 years of experience, currently serving as an architect in data science at Zone 24/7. His passion for harnessing AI tools is evident in constructing data-driven products and advanced analytical solutions, enhancing clients' decision-making processes. Nisal is a Microsoft certified trainer, conducting technical training programs and actively contributes to the tech community through informative articles and speaking engagements at local and international forums. Joining him is Mr. Ishara Navanjana, a result-driven and enthusiastic individual who serves as an associate machine learning engineer at Zone 24/7. He holds a BSc honors in statistics and computer science from the University of Colombo. Ishara specializes in computer vision, natural language processing, and generative AI, key areas of artificial intelligence. His dedication to ongoing enhancement is showcased through his efforts in developing AI solutions that effectively meet business requirements. Without further ado, let's welcome Mr. Nisal Mihiranga and Mr. Ishara Naranjana to share their insights on implementing generative AI models in practice. Over to you.
Thank you, Nipun. And hi, everyone. Good evening. I hope you all can hear us. Right. Let me quickly share my screen. Can someone confirm whether you can see my screen?
Hello, yes, we can see your screen.
Right. Okay. So I think you all been had a fantastic journey throughout this AI Bootcamp series. So you had previous 3 sessions on prompt engineering and various fine tuning and other mechanisms related to large language models. So I hope you all are comfortable and you uh, grasp certain areas which can be utilized in your hackathon, which is going to happen in another week or so, right? So today, our focus is how to implement large language models in a practice. So, what are the things you learned already throughout these prior 3 series? So, we'll do a short recap. After that, we will get our hands dirty. So, we'll do some practice session, practical workshop. So, I hope you all make ready yourself with your laptops and we believe that you already got the prerequisites document, which compiled based on this workshop today we are going to happen. So, I trust that you already installed certain necessary libraries and all. In case of you couldn't install, just that's fine. Just check that. I hope you all receive that via an email. So just make sure that you have set up that. So then you can contribute and while we are doing the workshop, so you also can try out yourself by doing that. So it will be a totally hands-on session today, right? Okay, so since Nipun already gave us gave an introduction about myself and Ishara, so I'm not going to spend much time on this. Myself and Ishara both worked at Zone. So as a company, we do a lot of research and development, AI, and machine learning, and embedded engineering and software engineering work. So from hardware to software. So we have built a couple of AI products, largely based on computer vision. And also there are some other data science related products as well. So that's pretty much about the company we are working. And also in my career, I have been working for software industry more than 11 years. So mainly on data side. So I started my career as a software engineer. Then I moved to data science, mainly data. At that time, as a database developer, so I worked on the data warehouse development and the ETL development. Now we call as a data pipelines. So I have done several implementations on the data warehousing and business intelligence solutions. Then slowly I moved to experience with the data science and machine learning and advanced analytics. So that's pretty much about myself. So Ishara, would you mind to intro yourself?
Yes, sir. Hope I am audible.
Yes, can hear.
Yeah, so I am Ishara Navanjana from 724/7, and I'm currently working as an associate machine learning engineer at 724/7. So as Nisal mentioned, we are mainly working on computer vision products, and as well as we are trying on different natural language processing and large language model products as well. So going forward about my education background, I completed my BSc degree in University of Colombo with a background in statistics with computer science. So those helped me to develop develop in my career as a machine learning engineer. So over to you, Nisal.
Right, thanks, Ishara. So that's all about us. Let's move into the session today. So this workshop, the objective is will give a comprehensive understanding about the principle of and practical implementation of the RAG, or in other words, retrieval augmented generation, which is a great way to you can fine tune or customize large language models for our requirement, right? By now, I know that you already covered certain things in the previous sessions. So let's do a quick recap. So we are not supposed to spend much time on the theory part today, because this is going to be a largely hands-on session. So we'll do a quick recap, since some days we covered those theory and the previous session. So before we are going to the hands-on, let's do a quick recap, right? So how to make LLMs align to your requirement. So you already know that there are 4 main ways that you can do customize large language models. One is prompt engineering. You know, by now what is prompt engineering? Basically, prompt is the text input you are passing to the ChatGPT or maybe Google Bard or any other language model in order to get the retrieve the output, right? So you know that so by tweaking that text you are going to input, you are inputting, so you can get the desired results and you can optimize it if you know well how to engineer the prompt and how to customize it to get a better way, so you can harvest the maximum out of in that model. You can achieve the best performance. So the next one is retrieval augmented generation, RAG. So which is essentially we are going to cover today as a technique which we can customize the large language model for our specific requirement. So if you are already aware that nowadays it's kind of a hot topic, everyone talking about RAG and how to implement that RAG pipelines for various applications. So the third one is the parameter vision fine tuning. Okay, I will give a small intro to that and also fine tuning. Before that, okay, I want to all of you to see this slide. So you know that large language model by name itself, so it's a huge. You know that in a train large language model from the scratch, especially language model like GPT. So it's not the easy thing. It's a very resource intensive and time incentive task. So usually we as companies, I don't think that we can do that. So it's a require a lot of computation power, like a lot of arrays of GPUs. So these are hypothetical example how big LLM, right? So Meta or Facebook, they released their open source LLM. One version is 70 billion parameters. There is another one called 7 billion parameters. So it's also, if you download really, so you will get the 2 files, basically the model file and the parameter file. So the parameter is somewhere around 8 GB. So the requirement for training and hosting that require a lot of GPU. So this is a kind of a illustration for you to understand why fine tuning is not easy task for us to do because it's require a lot of computation power, right? So in this slide, you can see the full precision model, the fine tuning, which if you have a 1 billion parameter model, so which required nearly 4 GB 32 GPU to do that, and also if it is a 16-bit quantized model. Quantization is a technique in the deep learning and machine learning to downsize the model in order to deploy and run in the low power machines like embedded devices, IoT devices, and etc. So if you halfway downsize, so it's still it's required 2 GPU, and if it is 8-bit quantized model, then 1 GB. So likewise, you can imagine that how hard this task if you do the fine tuning, right? So if you already know that GPT-4 and GPT 3.54 it's somewhere around more than 100 billion parameters, right? So think about if you put yourself in the spot, how to do that. It's not merely impossible for us to do that, because it's require a lot of computation and the resources to do GPUs and all, which the simple word, which is very expensive. That is why these prompt engineering and RAG and other techniques there. So I will explain a little bit about the difference between the parameter efficient fine tuning and the fine tuning. So fine tuning means you have a base model, right? You can optimize or fine tune the generic model for a specific requirement, which is called fine tuning, right? But this evolves to fine tune all the parameters, right? The last one I'm referring to. So if you fine tune, which required, as I mentioned in that other slide, it's required a lot of computation power. So what is the parameter efficient fine tuning? Which means, so we are not fine tune all the parameters, because it's a very resource intensive. So we freeze a majority of the parameters, and we fine tune only minor or subset of the parameters for a required or specific task. That is what we call parameter efficient fine tuning. One of the famous technique you can use to do that is LoRa. You may already heard about that. So you can see in this diagram, it says the complexity going to increase if you're going down. So to do the prompt engineering, you don't need to have any GPUs or anything, just a browser, and you can access the using your web browser, GPT or any other language model. So you can just tweak the text and get the different outputs. So the other easiest way is, and the very popular nowadays, is the RAG, or retrieval augmented generation, where we can fine tune the large language models like OpenAI GPT, Palm 2 by Google, and there are other popular language models. So you can fine tune that large language models for our requirement, like in the sense we can use our own private data, right? Our personal data, like even corporate data. We can point to a database or any series of documents, and basically you can ask questions and get the output. So that is what it's doing using RAG, or retrieval augmented generation, right? I hope you got the recap of what I expected. So these things you already learned from the previous sessions. So I will quickly move into the next slide. So what is RAG? So here you can have your own source data like documents, databases, and even you can get the data from the APIs, right? So in here, what we do some kind of a technique or computation process called indexing. It's quite similar to database indexes, if you may wondering. So what we do, we arrange this textual corpus of data, our source data, in a way that efficiently can retrieve, access, and query for the giving relevant specific responses to the end user. So that is what here we do using RAG, right? So you can see in the diagram. So it's indexing process happen, then so firstly the user query the data, right, from the LLM, and the same question goes to the indexing, and it's locate the most relevant answer or the content, which that context goes to the LLM, then it's combined and give the response. So it's like so GPT, it's fine-tuned again. It's fine-tuned for the chat conversations. I mean the chat GPT. Likewise, you can do these things for your own specific data. There are many examples. So if you want to build an application to a company for the support ticketing system, support chatbot, or any other, even the customer service or any other application. So you can do, if you have the data, that specific data in a format like text, PDF, any format, so you can implement that requirement using RAG. Okay, so stages in the RAG pipeline. So we'll do the loading, load your data. Then we do that indexing process, then storing the database. So in here, it's storing the vector database. Vector database is a very specific database, which is optimized for the fast retrieval. Then query the data, and then the evaluation process happen. So this kind of a pipeline or series of sequence of processes we are doing in the when you implement RAG architecture to do the fine tuning, right? Any questions so far? So if you have any questions, feel free. You can ask. I think the best way to do that is you can just drop on the message window. So we will answer as we go. Right. Okay. So now that's the recap, the theory part. So let's move to the practical of it. So today we are going to have a use case, right? There's a company called Hypotech, right? So they are just this is hypothetical scenario. So they are a product company. They want to ensure continuous support, and they need to always give the very smooth service for their customers through their support ticketing support system and support channels. So they want so kind of it's you know that one way for the business, it's really important, especially for product companies, to maintain the customer satisfaction and get the best, maintain the good customer, loyal customers and all. So the quality of the support system is really important. So in this use case, this company Hypertech, so you need to develop an application using LLM to support to build a chat application, then that able to support the customers customer queries, and whenever the customer asks certain questions about the product information and all. So this application we are going to develop today will be able to respond, right? So that is the use case. So this is kind of a solution we are going to develop. So underneath this is there in our code develop. So we have the document. So we will provide the relevant document to you. So we are pointing that document because we need the that personal product related information in order to give relevant responses to the end user whenever the customer asks certain questions related to the product information, and also then so we need that. And so we'll be using embedding model. In this case, we are using Hugging Face, and we do that indexing process. And as I mentioned, we do indexing in this RAG pipeline, and also we need to store that data in a database. It's a vector database. So for that, we are using Llama indexing. Then, okay, that's it. So we'll be using a language model. So for today, we'll be using Palm 2. It's an open source large language model by Google. So you can access freely to the Google Palm 2 model and to do implement this application, right? And so you can see here this vector store. So when you query question, right? So there is a ranking process happen based on the information or document information. Then how, so you can fine tune as well. So then this is how it's give most relevant response to the user, right? Okay, so tools and technologies to build an application, or also in other words, RAG pipeline with the front-end application to do this task. So we need the LLM framework. So there are multiple ways you can do, even multiple techniques, architectures you can use, like LangChain and all. So we'll be using Llama Index to build the RAG pipeline. And for the embedding model, we are using Hugging Face. And the vector store, so there are many vector databases available. Those are free, actually. Some of are free, like Pinecone, ChromaDB, and all. So here we'll be using in-memory DB vector store in the Llama Index. And for the model, we'll be using Google Palm 2. You can use OpenAI GPT also, but it's a paid one, you know that, so you need to pay for that. But I think you can use either Cohere, or there are several language models, open source models, and also so I think it's worthwhile to explore those things as well, since you are practicing to build the LLM applications. So after that, we need to have a front-end application, like a web interface for the customer or the user to interact with the our application. So for that, we are going to use Streamlit to build that. Flask also an option you can try out. But for today's session, we'll be using Streamlit. All right, right. So that's about the slides and the theory and the recap. So I will hand over to Ishara. Ishara, so you can share your screen and start the demo session. Thank you.
Thank you very much, sir. Hope you can see my screen.
Yes, can see.
Yeah, so this is the hypothetical scenario we talked about earlier. And here we have some common customer queries, like some queries about smartphones. So here you can see the first question is, my smartphones battery drains quickly, and can you help me troubleshoot the issue? So likewise, we have some common queries about smartphones. So we are going to use this document in order to build our RAG pipeline. So I will share this with you so you can download this and one second. So I have added this Google Drive link to the chat. So can you please download this document? So after that, let me know by raising your hand or some emoji. Yeah, one person has downloaded. So let us wait for some few minutes. Yeah, I can see some people are raising hands now.
Right. I think Ishara,
Yeah,
we can continue.
we will move forward. And so then we need to create a Google Colab environment. So for that, go to your drive and then you select new and then you can select more and the Google Collaboratory. So from that you can get a new Google Colab environment. So shall we do that quickly as well? So have everyone created a Colab notebook in Diva? Please raise your hands if you have completed that step as well. Thank you. I think we are good. So we will move forward. So first of all, we need to install some libraries. So as Nisal mentioned, we are using Llama Index for these lab sessions. So I have added the links for the modules we are using. So here, if you go to Llama Index, so this is their web page, and you can see that they are providing some inbuilt functions and classes that we can use to build some very complex rack pipelines, and also to evaluate those pipelines. They have mechanism for those things as well. So, and then we are using PyPDF. So this is to read PDF files. So actually, there are some functions in Llama Index that which is using for uh, loading these PDF files. So to load these PDF files, we need PyPDF, and then we are using Google Generative AI. So this is for our large language models like Farm2. And then we are also using transformers from Hugging Face. So I have added these links here. So if you want to read more about these libraries we are using, so you can go to these links and check whether about those things. So at the end of this session, we will also provide this notebook. So you will be able to go through these things. And so the first thing we are going to do is importing the libraries. So to do that, so we need these four libraries: Llama Index, PyPDF, Google Generative AI, and Transformers. So I hope now you have created the Colab environment. So now we can start installing these libraries. So we are going to import libraries with some specific versions, so which will be helpful for future preferences as well. So the first thing we are going to install is Llama Index, and then we are going to install PyPDF. So the version of PyPDF is 3.171, and then we are going to install Google Generative AI. Version is 0.2.2, and then we are going to install transformers. Version is 4.352. So now we can install these libraries. So first, this environment need to connect to a runtime, and after that, this will begin installing these libraries. So now I have finished completing these installing libraries. So can anyone respond that you have finished this step? So please raise hand if you have finished this step. We will wait 1 more minute until others will be finished. So if anyone has missed this step, and Nisal, shall we share this code line in the chat? So I will move forward with the next step. So the next step will be to import necessary modules from Llama index. So I will import and the vector store index. And also from Llama index, on Llama index, I will go to embeddings and then import Hugging Face embeddings. So I will go quite slow so you can follow up with me. And then I need to install the module. So if you see that these are the functions available. So here I will import LLMs and then farm for farm model. And then I will import the service context, which will be required for creating our lag pipeline. So service context. And finally, I will import the OS for to get our API keys. So hope you all followed this section as well. So let me know when you have finished this important part as well. So please raise your hand.
Okay, one question. So where's the blank collab file? Was it shared to make a copy from? Okay, so you can create a blank one. So you can just go to your Google account and create a collab file. So anyway, the information and all this uh, collab notebook so will be shared at the end. But for you to start, you can start with the blank file.
So is everyone finished with this step? So if you are able to try this one, so you can see whether this is working correct. And also, if you have any further questions, you can easily understand this and ask them as well during the Q&A session. So it will be better if you can try this one with me. Okay, so I will move forward with the next step. So the next step will be to create a data folder so we can load our document. So now if you go to this file section, you can see the created data folder. So in this, you can upload your document. So this is the document I have shared with you. So I will upload this document. So here now you can see that we have products.pdf file. How many of you have finished this step? Can you please raise your hands if you have finished this step? Please keep your raise hand for a few minutes so I can get a count how many of you have finished this. Thank you. So I will move forward with the next step. So our next step will be to load this document. So here you can have multiple PDFs as well. So there are some inbuilt functions to load data from different sources. So when you go to the Llama Index documentation, they have Llama Hub, which will have many different data connectors available. So you can load this data. But here I'm going to use simple directory reader. So from that, we can load images, PDFs, Word documents, or markdowns, and any number of files in the folder. So let's import. And you need to give the path. And then we can load the content in this folder. So now let's see what we have been loaded. Okay. So now here you can see the products.pdf file which was in the data folder has been loaded, and they have created the IDs, and also they have added some metadata. So they have about 4 pages. So they have read these all the pages. So here you can see page level 2. Likewise, they have loaded this document to this variable. So how many of you finished this step as well?
Ishara, could you please put the PDF file link into the chat?
Okay,
I think the participant who joined lately, they can't access that time, I believe.
okay. I have added that link again. So if anyone has missed, you can download this from that.
Okay, uploading PDF part wasn't clear.
Yeah, how to upload?
Right. Yeah. Yes, Ishara, you can.
Yeah. So to upload the PDF, you can go to this file section in the column notebook. So then you can go to this data folder which you created in the previous step, in the third step, and then you can select this, and then you can upload the file from this. So then
Yeah, if you want, you can create a folder manually. But we can use the command also, mkdir, make directory. So you can create a folder and then you can upload manually.
So can we get a count about how many of you have finished this step? Can you please raise hand?
Excuse me, sir. PDF link is received us. Did you send it from Zoom chat or?
Yeah, I sent it in Zoom chat.
Yeah, I just
now
shared again. Can you see?
Now can see.
So if you have missed any steps, you can add this add a question in the chat, and Nisal will share the code for you for this specific step. So how many of you have finished this step? So if you have any different kind
Yeah,
of
uh, Ishara, can you show again the load the load data function, the
yeah.
code separate for that?
So were you able to finish this step? I am seeing only few students are raising hands. So if you're not able to follow this step up until this step, please add a message in the chat. So I will move forward.
Yeah, just hold on.
Yeah.
No, a few participants, I think they got an error. Rajivan said, I am getting a value error using the load command.
So before that, there is a message from Shafran. Hope I pronounce your name correctly. And you can follow up with the further last steps, Shafran. So it is not, it is a warning and it won't affect the code. So you can import the necessary modules. So if the document didn't load, so you need to make sure that the document is uploaded in the folder correctly. So so are there any other
Yeah,
questions?
just make sure you have uploaded into the correct folder. For example, in this case, Ishara has created a folder called, it's uploaded into the data folder, right? So the part should be corrected, in order to load it correctly. So you can see in the file browser, it's under the data folder. So that is why we used data, right, to locate the directory, read the data from directory.
So shall we move on with the next step?
For the one student, MKDIR. Okay, so it's a command line. I mean, command. So you need to use explanation mark before that. Ishara, can you show that also?
Yeah. Hope everything is fine now.
Any other question? Mohammed says document is not loading, but command is running without errors. So when you say Mohammed, document is not loading, when you execute the documents cell, doesn't it show the output?
Yes, sir. The output is not showing, but I have attached the screenshot as earlier. Shall I put it again?
So, Mohammed, do you have a folder called data created in the file section?
Yeah, Mohammed, what you can do, just click the left hand corner of the menu bar. There's a small folder icon. Just click it, so it will expand the that browser window, file browser window. So in that, see whether the data folder is being created, and there should be the file product.pdf file you uploaded inside that. So then only you can load it. So can you check whether you have done those steps?
Yes, sir. It's there, but I have changed the document name. Is it a problem? just we are adding directory, right? Then it won't be a problem if I'm changing the name.
Yeah, it won't be a problem. So
Yeah,
Mohammed,
everything is fine. Everything is there.
Yeah, can you print the output from the documents?
The problem is output is not showing. The command also says okay.
So
With
what is
the
the getting for
green
that
tick.
step when you are running the when you are trying to print the documents?
I posted the screenshot as well. The file is there.
Maybe you have there are some spaces in between, right? The file name.
So that can be a problem. No? Okay, I'll upload something like okay.
So yeah, we'll come back to that, and in the meantime, we will go with the next step as well. I think that will be better.
Yeah,
So
Mohammed. So if you need just you can use underscore, just like the other sample files being uploaded under the sample underscore data.
Yes, sir.
I mean, if
I'll
you
do that.
really want to separate the words, otherwise just rename just simple one like product, not PDF.
Okay. Okay, I'll do it.
Right.
let
Yes,
me
Ishara, I
summarize our
think
step.
you.
So this is the step for loading data. Yeah, so next step would be to get the API key from farm to model. So to get the API key, so we need to go to the farm API. So you can go to this using, you can search farm API. So when you go to this one, you can go to explore the API, and then you can select get your API key. So then you will be redirected to this marker suite page, and then from that you can generate the API key. So here
Ishara, can you show that steps one more time?
yeah, I will show you. So first you need to search farm2 API and go to this farm API generative AI for developers. And then go to explore the API. And from that, you can go to get your API key. So you will not receive this message. This is due to a organization account. So I will use my private account. So from that, you can get your API key. So you can select this one. So it will generate the API key. So you can copy this API key. Hope these steps are clear. So if you have any questions, you can drop them in the chat. And also raise your hand if you have finished this step. so we can get a count.
Yeah, this step is quite similar to if you are developing an application using OpenAI model, right? So you need to get an API key in order to securely communicate with the language model. So in this case, as you mentioned earlier, so we are using Google Palm 2 API, their main language model. So do this workshop. So the process will be quite similar. So you need a key. So this is how you can obtain the API key.
And also, if anybody couldn't do these steps, and there are some people who have completed these steps, so they can also help others as well. So it will be easier. So now you can copy your API key and then go to the notebook you have created, and then we need to set the Google API key for Palm model. So here I have added some details about the Palm 2 model as well. So you can refer this in later. And also this Palm model is sectors in reasoning tasks and also code, mathematics and classification and question answering tasks. So this is quite good model. So it won't have the performance of GPT-4 model, but it is quite accurate in order to use in some question answering tasks. So now I'm going to set the API key. So raise your hand when you have finished this step as well. So I can see few persons have finished this step. So any questions if you have heard during this step? Plan news call from top to bottom after plan the API key, please. Okay, you are ready to. So now these are the steps we have followed. So first we have imported these libraries, and then we have imported these modules from those libraries. Simply directly read data for load documents, and for indexing we are using vector store index, and for embeddings we are using Hugging Face embeddings, and we are using Palm model, and also to generate queries we are using this service context. So after that we have created this data folder, and then we have load our document PDF file to this data folder. We have uploaded this, and then we have load this PDF file using simple directive reader and the load data function. And then we got the API key from PARM to a model. So the next step will be to initialize the PARM model. So for that, you can for this model. So are there any other questions regarding this? So since I am not seeing any questions, I will move forward with this. So now we have initialized the PARM model. So now next we need to create embeddings for these documents. So to create embeddings, we are using Hugging Face Visual RGN embedding model. So if you go to this, so this is the embedding model we are using. So to go to this one, so you can simply type GA large GN version 1.5. So you will be redirected to Hugging Face, and from you can see the model card for this embedding model, and from I'm copying this one. So if you want to, you can type this one as well. So there are some details about this model as well. The results were quite good with this model. So you can see this one. So if you want to read further about this embedding model, you can go to Hugging Face and refer this one. So hope this step is also clear. Go to the Hugging Face and check in on that Hugging Face embedding model. So now I will initiate the Hugging Face.
Ishara, can you share the URL on the chat?
Yeah, I will share this one. I shared the link for this embedding model. So now we will initialize this Hugging Face model. So in the meantime, if you have any questions, you can ask them in the chat. So we will look at the chat as well. So you need to give the model name. So here you need to give only the model name. Yeah. So then we can load this embedding model. This should be the attribute is model name. So we need to search model name. So when you have finished this step, please raise your hand so we can get a count on it. So meantime, if you have any questions, please add those in the chat as well. Since there are no questions about this step, we'll move forward with the next step. So, and also I have provided a link about embedding. So if you want to learn more about embeddings, you can follow this video lecture series from Google. And also, if you want to know more about some different techniques of embeddings like word-to-vec, and so I have a reference for that thing as well from TensorFlow. So, are there any other questions? Shall we move forward? So, if you have any questions, please add them in the chat. So, let's create the service context. So we will use the service context to index the documents. So you can see the next step will be the indexing part. So to do the indexing part, we need to create the service context. So for to do that, I will import the service context. And then from defaults, you need to give the LLM. So we have initiated the farm model as our LLM model. So you can see this step. And then you need to give the embedding model. So if you look at the arguments here, you can see we can give the embed model. And by default, this is using the OpenAI model. So if you are using using the service context without the LLM, so you need to have the OpenAI API key. So the embed model.
Yeah, Ishara, okay. Tommy said lost it after document. Okay, after the loading. How many lost the way after that? Or is there many or only few? Because while Ishara is continuing, I may be able to share the code up until now. Then we can save some time, right?
Yeah, there are a few steps, so I think it will be better if we go in that way. So next we need to give the chunk size and the chunk overlap. So with this chunk size parameter, it will basically what we'll do is it will chunk your documents, the uploaded documents into different small chunks. So this will, so we are going to give the chunk size as 800 and the chunk overlap. So this chunk overlap needs to, so when you are chunking a document, so we don't have idea about the relationship between those chunks. So to give that, we are having some overlap in these document chunks. So I will give this chunk overlap to 20. So now we can create this service context. And the next step will be to do the indexing part. So before that, can you please raise hand if you have finished this step? I will wait 1 more minute until a few others will also finish this step. And also please make keep your raise hand for a minute so we can get a count with your number. So meantime, you can add any questions in the chat as well. So we move forward with the next step.
One
now,
question, Ishara. So what is the tokenizer? So actually this is directed to me, but I will pronounce it for other also. So what is the tokenizer do? And so that it's loading when we initialize the Hugging phase. Ishara, would you like to explain? Or
yeah. So in this one, when you have a document, then this we have now PDF document. So now we have to make this document readable for the model, we need to create embeddings from this model. So to create embeddings, we need to first do some pre-processing step to documents. So like we need to tokenize these documents into words. So, and then we need to also do lemmatization or stemming. So then these words will be changed to their root form. And then after that, we can get the embeddings. So before creating these embeddings, we need to tokenize these documents into smaller parts like words. So that is why we need tokenizer in this embedding model. I hope you got the answer.
Yeah, it's some basics in the natural language processing or NLP. Basically, you need to process and train the language or like chatbots and all. So you need to do some pre-processing like tokenizing is the one, right? It's a concept basically. It's a even any language that functions are there. Like you can do the string tokenization, like word by word, and all you can do that computation. So in this case, in this context, when it's come to NLP, so to understand the meaning and the context, so do tokenize words, right? Then we'll be using various embedding techniques like vectorization and all to do the before the training. That's help to do the kind of optimum computation for the training, because you know that we are talking about the sentences, words, and a lot of text data. So that is why it's a must to do some pre-processing before doing the model training and that stuff. So in this case also, so in RAG, so we selected our personal document in this context. In this workshop, we shared the product PDF, right? So the same steps follows before we are storing data in the our database, vector database. Yes, Ishara.
Yeah. So now let's move forward with the indexing part. So now we have loaded the documents as well as we have created the service context, and also we have got the embedding model from Hugging Face as well. So now we have all the necessary equipments to create the index part. So before that, so when you go to the Llama index documentation, so here we can see some details about vector store index and what is their functions in their class. And also there are some functions and we are using this function called vector store index dot. We are using this function called from documents. So here you can see this function. So from that, we need to give the service context, and also we can give the storage context. So in this, if you are defining a storage context, like if you are using some sort of a vector stuff, so in that case, you need to create this storage context, which in which you are going to store these indexes. Since we are using this vector store index from inbuilt function from Llama index, we are not using this one. So if you want, you can use a different sort of a vector store like DB or any other thing. So in order to use that, you need to provide this storage context. And then we have created the service context, including the language model and the embedding model and the chunk overlap and the chunk size. And also there is another argument called show progress that to show the progress of the indexing process. So now we can use this one. So we are going to use this from documents function, and we need to give the documents and the service context. You can see this one, and we have defined it as service context. And then we also need to, it is optional, so we can also show the progress as well. Yeah, so let's now create the index for this document. So now here you can see it is passing the nodes and then generating embeddings from the model we give. So now we have created the embeddings from the vector store index from llama index. And so how many of you have finished this step? Can you please raise your hand? So if you have missed any previous steps, please add them in the chat. So Nisal will provide you the necessary codes for each step. So you will see the complete end-to-end product in the later in this session as well. So you will be able to create a web app using Streamlit if you have finished these steps. So also if you have any questions, please add them. So I think we can move forward with the next step. So are there any questions in the chat? Yeah. So the next step will be to store these indexes we have created. So if we are going to create indexes every time we are using this model when we are querying, so it will be a cost, we will have a cost of indexing. It is not the efficient way. So we can use the built-in persist method to any kind of index to store these funds. So it will provide these indexes, created indexes into the disk, into a location we have. Can use any sort of a vector store. So I have added this link. So this is the easiest way to store these indexes, and we will use this step. And apart from that, you can use some vector stores like ChromaDB. So in their documentation, they have provided the code to get these ChromaDB and how to initialize this ChromaDB, and created the vector store index from these in the documents and then storing the ChromaDB. So here we can see they have selected the vector store as Chroma vector store. So then they have defined the storage context, which I showed earlier. When you are using this from documents function, you need to provide storage context. So apart from that, they have the support for the other vector stores as well. So now these are some of the options available. And also they have provided example if you are using any sort of a different vector store. So now we are going to use function, which is from the vector store index. So here you can see. So we are going to use so this is documentation. If you go to index storage context persist. So we are going to use this function to store these indexes into our folders. X dot persist. So hope everyone is finished this step as well. Raise your hand if you are finished this step.
There are
And
few
also,
hands.
yeah. And if you have any questions up until this step, you can ask them in the chat as well. For now, if you look at these files, so you can see there is a folder called storage. So if you go to this one, so these are the files that I created in this indexing step. So you can see this is the index.json file. So they have created the nodes from these documents and have saved them. And also if you go to docstore, here we will have the document chunks. So these are the embeddings created. So each word will have a different type of number. So are there any questions regarding this step? So now we will move forward to the next step, which is the query. So this is just a prompt to an LLM, and so this then with the context we have given, the LLM can generate a quite efficient answer. So the simplest way to create a query engine is to get that query engine created from the index. So we need to define the query engine. So, and also I have created, added this link to query, and so if you go to Llama index and the querying section, so this is the documentation. So this is the basic function they have created for querying from a LLM. So there are 3 stages of querying as well, known as retrieval, post-processing, and response synthesis. So if you want to change those things, you can change in this query engine. And also if you want, you can create a query engine for yourself as well. And also you can customize these stages of query. So to do that, they have given these codes in the documentation. So you can try out yourself these things as well. So when you're creating a solution for a problem, so sometimes you need to create a query engine for that specific question you are solving. So you need to have an idea about what are the things you can configure and you can change in order to get high accuracy. So I will copy this one and then you can. So now we are creating a query engine from index. So now also then we are going to ask the question. So if you look at our PDF given, so let's go to the PDF. So there's a question called trouble connecting to the smartphone to the Wi-Fi network. So let's query this one. And let's query that. So now we have the response. So let's see the response. So we have, this is the response we got, and this is the response we have given in the document. So you can see that it has identified the question correctly and given the answer for a common question that people may ask. So how many of you have finished this step? So if you have questions, you can add them in the chat. So now we have created a simple RAG pipeline that we can use to generate responses for queries using Farm2 language model. So please keep your hand raised so we can get a count. So after this, we will look at how to customize this RAG pipeline and also how to create a web application using this RAG framework. So are there any questions in the chat?
So we can have this template which you are using for
Yeah.
this.
We will try to do after this session, probably.
Okay, thank you very much.
So I think few people are able to complete the notebook up until now. So now let's move forward to the next step, which will be the customizing this RAG pipeline. So the first one would be to use different response modes. So now we have created this query engine. So we can change this parameter response mode. So and then we need to give the response mode we are using. So you can select any response mode from this. So then you will be able to generate different type of responses. So according to your use case, you need to select your response modes. So now I will use this to summarize. So let's see what will be the response. Yeah. So now you can see we have got a different response. And also if you change these response modes, you will get different type of responses as well. So if you want to give more context to your language model, so if you look at some of the large language models available, even GPT models, and they have this context size. So we can only give about for the farm model, we can give about 8,000 tokens. So it will depend on the model we are using. For the GPT 3.5, it is about 16,000. So here we can give different type of we can give number to get the retrieve the node documents. So to order to change that, we can use this similarity of k argument. So if you look at this query engine, so now let's change this one. So similarity. Okay. So you need to give a parameter. So like this Q2. Now, if we look at the response, yeah, so this is the response. So if we have different type of, there are so many content in your answer. So changing this value will also change your responses according to your query engine. So have you finished these steps? Can you please raise your hands if you have finished these steps? Yeah. And also, if you have questions, please send them in the chat. Yeah, now we'll move on to another part in customization. So you also can customize your query templates. So in order to do that, you need to import the query from the llama index. So to do that, need to import prompt, and then you can define your QA template. So this is the template I'm going to use, and so we have given this context for the question. So and each answer should start with code word doc chat. And also, if the answer is not given the context, so it need to reply that it doesn't have this information. So we can it and give the template. So for this step, I will add
Ishara,
this template and this section.
Can you go scroll up and show the 15th cell?
So I have added this template into your chat as well. So you can get that. So this is the 15th one. So Muhammad, I have shared the template. Hope you received it. Are there any other questions? So now let's use this query template in our query engine. So here we can define our text QA template. And then we need to give our QA template. Hope you have finished until these steps. So now let's query this one. And also we'll in the response here. So now you can see it started with the code.docchat. So you can configure it to inline, and also it have provided the answer for our question. So likewise, you can experiment with these things. So now next we will move forward with our Streamlit application, which can be developed to use this rack pipeline. And also if you want to use Gradio, so this is a very simple interface. So you can use this as well. So it will be interface like this. So I will share this code after this session, and so you can try out this one as well if you want to use Gradio. So hope you have finished until these steps. Can you please raise your hands? Yeah, keep your hand raised for a few seconds so I can get. Yeah. So I think everyone is good with this part. So Nisal, shall we move forward with the Streamlit application?
Yes, sir. So before that, are you all good with this? Could you show the code 15? And also, just let us know on the chat if you have any questions or any clarification related to this before we are moving to the application development. So now we have shown you how to develop, how to use large language model and how to develop a REC pipeline. So in this today's workshop, so we used open source Google. Sorry, it's not actually open source, but you can freely use it. Google Palm to large language model, so you can access and develop this. So so far we have developed this, and now we have shown you how to query and get the response for you from the file we shared. So in your case, you can use the same code, and you can use different document, your personal documents or anything, and you can try out. So it's a good way. We hope that it's a good way you can play around this. So this will be, you hope this will be useful. Okay, there is a one message in previous step. I am getting error name. LLM is notified. Okay, this is where this I think the cell number. Ishara, can you go up? I think this very Um, just go down. Okay. Vidushan, can you explain where you are getting that error?
So I'm getting error in code 7. So LLM is equal to LLM equal palm. So here I typed correctly, but I'm getting error.
So what is the error you are getting?
So I'm getting like inactive RPC error. It's coming like this.
Can you share that in the chat?
And in last line
Yeah.
service and yeah.
Vidushan, if you can just put a screenshot of your notebook.
Yeah, sure.
And also, since we have to clone a repository for the next part, I will move forward with that, and by the meantime, we will solve your question as well. What do you think, Nisal?
Yes, we can continue.
Yeah. Okay. So let me share screen part. So I have created a repository in GitHub. So this is a public repository, so you can clone this one. And I will add this link to your chat. So I hope you all have created the folder and also create a project in your laptops, and also have installed the necessary libraries we have shared with you earlier before the session. So now you can clone this one into that project. So I will show that. Hope you can see my screen.
Yes, yes, Ishara, we can see.
Yeah. So we have provided you the get repository in the chat. So if you are not able to get that, please mention that in the chat, so we will drop that again. So how many of you have finished this step, cloning this repository? Yeah. So now we have installed here Streamlit and also the earlier libraries we have installed in the Colab notebook and also the PyTorch. So we need PyTorch to work with the embedding model. So we have installed these things in this project. So here we can see that so these are the libraries we have installed, and in order to get this, you need only these ones. So we have shared a document called PDF sites. So in this, you will have these libraries which will be needed to install.
Yeah. So just out of curiosity, how many of you haven't installed these libraries before? I mean, how many of you were unable to install it before the workshop today?
So I have added the command and the necessary libraries into the chat as well. So you can install these libraries when we are doing this, creating this Streamlit application. So now go to this app.py, and here we have added that so go to this rack with palm.py file, and here you can see that this is the code we have tried in the Colab environment, and we have created this as a class, and also then we are going to import this class to this Streamlit application. So let's move forward with this step. So if you look at this one, so here we have this data folder in the storage. So it could be better if we move this folder to the rack folder. So I will do that. So if not, you can change the path to the this data folder as well. So this is the folder. Now we can go to that rack folder. And then we can run this Streamlit tab. So to run this Streamlit app, you can run Streamlit run app.py command. So I will have this one. It is attached. Now you can see it is loading. Yeah, so in this one, you need to add the API key. So here, go to this rack with palm.py file, and here you need to add your API key, which is generated earlier. So this Colab notebook. So get that API key. And then add this API key into this one. And then you will probably able to run this one. So there is a requirement for installing this library, which I have added in that document. But let's install that as well. Can change this to query engine. So now here you can see that we have created these applications, and if you want to change these names, you can do that also. So now if you go to this one, so this is our Streamlit code. So this is in Streamlit, they have created some example codes for generating chat interfaces like ChatGPT. So like if you want to change this, So you just need to define. So hope you can see my screen, web browser.
No, Ishara, we still see your ID, Paisha.
Yeah, sure. So I will. Hope you can see my screen now.
Yes.
So this is the application we built from Streamlit. So if you want to check more about these applications, before that, let's query some common question. So you can see it has given the answer. So if you want to check another one, so let's go with. So let's get this question. Battery brains quickly. So here you can see it can provide the correct answer from the document. So likewise, you can create any customized applications using Streamlit and also the direct pipeline we have created. So you can connect to a large language model. You can use Palm 2 as well as if you are going for open source ones, you can use Cohere as well. So in Cohere, there is a model called Command. So you can use this model as well without a cost. And also, if you are looking at this Streamlit code, so I will share this code with. So this is the Streamlit code, and actually in this one we imported this class called drag query, which is built from the code available from the Colab notebook. So we have just created a class from it and get that object, created the object, and then so we have created uses that Streamlit documentation, and in that one you can get how to create this sort of an interface, and after that we just need to get the prompt from the user, and then you can use this created class called rapid farm, and then you can call this function called query response and include your prompt. So here you can see this is the function we have called it to query and get the response, and then Streamlit would save your chat according to the roles, and then it will displayed in your interface. So now I will go to Streamlit documentation, and so hope you can see my screen, and So you can search for the Streamlit chat app. So here you can see the documentation, build a basic LLM chat app from Streamlit. And here you can see they have some inbuilt functions for this one, chat elements, and from using these elements, you can create a customized web application. So here you can see. So this is the basic one. So you can try this one, and then you can see this is just printing the output. And then also they have shown how to use some charts as well. So since this is a Python library, you can use this charts, create charts as well. And so then they have created this one to build a simple chatbot GUI with streaming. So this is an example, the example we have got to create our application. So you can copy this code and change, you can create the Palm API as a class, Palm method as a class, and then you can add this one to get the response. So then you will have an interface like quite similar to ChatGPT, and also you can customize this to add documents into this interface add documents from this interface as well. So hope you have able to come to this part, and can you please raise your hand if anyone was able to finish these steps? Mohammed, yeah, there are 2 participants. So now if you have any questions, you can ask in the
How many
chat.
of you get this? Able to run the Streamlit application and perform some conversation?
So can you all please raise your hand if you have completed this step?
Yeah, there are few, there are some, right? Which means like some of you already able to run this application successfully. So there are other options as well, but you can use Streamlit. Even I think you are in another few days you'll be okay. There's a one request. Can you go through the steps in brief again? So do you want from the very beginning, or you want the latter part, like the run the Streamlit application?
Just run the Streamlit application, sir. I want that.
Right. Ishara would be mine to do that.
Hope you can see my screen.
Yes.
Yeah. So now we have created the folder project called LLM app, and then we have installed the necessary libraries. So we have given you a prerequisite document, so which included the libraries that we need to install. And then we moved with the, so I will go with the terminal here. So the next step will be to clone this repository. So I have created this repository in GitHub and shared with you the link. And it is a public repository, so you can clone this one. And after that, you need to go to this rack folder, which will be cloning from this repository. And after that, so here we have this data folder, which will be similar to the Colab environment. And so here, since this data folder was in the storage folder, I have moved that to the rack folder. And also then this folder has this PDF which we shared earlier. And then we have created this class called rack farm query. So here we have imported these modules from Llama Index. These are the ones we have imported in the Colab environment as well. So we have created a class, and in this class we have created this data folder if it not exist. And also we have loaded this document. So if you have the document in another folder, you can change this path here, and then you can load data. So to load data, we have used simple directory reader from Llama Index, and then you have to provide the API key. So if you are providing the API key, it is better that we can use this as an environment variable in your project. And also then we have initialized the farm farm model, and then we have initialized the Hugging Face embedding model, which we have used earlier. And also we have defined the service context as in the previous one, and also the indexing part from the vector store index. And then we have stored these created indexes. So if you go to storage folder, so here you can see the JSON folder, JSON files have been created with including these embeddings and also the indexing parts. And then we have created this query engine. And then to query from this query engine, we have created that function called query response, which needed the query from the user to give you the response. And then we have get this class into our Streamlit tab. So we have imported the Streamlit and also this class. And then we have initiated this class, and we have created the object from this class. And then we have added the title for our application. And then we have created this Streamlit session state messages appended part, and also then we also displaying these chat messages from history. So to add that, we need the list, and also then we are adding these messages according to the role. So role and the content. So here we have the roles of user and also the assistants. So there are two roles, and according to these roles, the chat history will be appended. And also in the prompt, so when user added the query, this will get into this prompt variable, and then we are using this prompt variable as the query for to get the response from our created object. So we are using farm2 model, and so this query, so we are getting the output from the farm2 model to give as the response in the application. So hope you able to understand these steps.
I hope you clear, right? So anyway, this code is being shared, so you can rerun and you can go through this code. So actually here, just give a glimpse of it. So this basically the same thing we developed the Colab. So the real world application, so we cannot run it on Colab. So you need to have a project and application. So for this interfacing part, we have used Streamlit. So it's a good, as Ishara mentioned, and he walked you through the documentation as well. So pretty easy if you know Python, so you can easily build data applications using Streamlit. So this is all about that. I hope you all achieved our objectives and able to develop a application pretty quickly. I think, Ishara, do you have anything else to cover?
Yeah, so I think we have covered all the things from creating a rack pipeline and also how to use Llama Index to create this rack pipeline. And then we went through the loading part of the data, and we use simple directive reader to load this data. And also then we have created the indexing part for using simple vector index from Llama Index. And also then we went through the query engine in Llama Index. So if you go through the documentation in Llama Index, they have given you the steps to, if you want to customize your rack pipeline, and also the steps to evaluate your rack pipeline. So how it is working according to your expectations. So in order to evaluate this, there's a part in the documentation, so you can check these things before you are going into a hackathon, and I think it will be beneficial to you to get an idea about how to improve your rack pipeline or how to improve your solution in order to get better results. So that's all from our end. So if you have any questions, you can ask now.
Yeah, so we'll be sharing the template and the code base with you. Any questions before we are wind up?
And also, if you want to use OpenAI models, if you have an OpenAI key, so I will quickly show a demo of that as well within few minutes. Is that okay?
Yes, so Ishar, you can just demonstrate that part as well, since we have 10 minutes left.
Yeah.
Just for your information.
Hope you can see my screen.
Yes.
So as in the previous Colab environment, we have installed these things. So same libraries, and then also we have imported these modules, and we have added the storage context if you are using any vector store. And also we have created the data folder, and also we have used this data loader. And then here we need to give this OpenAI API key. So here I have added this API key into a secrets in Colab environment. So here I have added this key. So then you can get this key and set your environment with your OpenAI API key. And after that, so as in the previous steps, we have created the service context. And here we haven't defined the LLM model. So here we haven't initiated this, like in the previous notebook, we initiated this PAR model. But here Llama Index service context supposed by default the OpenAI models. So if you have provided this OpenAI API key, you don't need to mention the LLM which you are going to use. So then you just need to give the embedding model and the chunk size and chunk overlap. So here it will go to this OpenAI environment, and then as in the previous steps, we have created the vector store index from the service context, and then created this query engine. And then we can use the same steps to get the query and the response. So it is simple as that, and so you can get your RAG pipeline completed with OpenAI. So here, as in the previous steps, then you can load this document and see whether it is loaded correctly. Yeah. And then so you can see we have got the output from OpenAI model as well. So you just had to give the OpenAI API key and then initialize this service context without the LLM. So it will by default go to OpenAI. So if you want to select models, there is argument to do that as well. So you can select which model you are going to use, GPT 3.5 or GPT 4. So that is about how to use OpenAI in a RAG pipeline with Llama Index. So if you have any questions, you can ask, and also later if you have asked any questions, you can reach out to us through LinkedIn as well. So we will be able to provide you help with building customized chat applications with large language models.
Great. I think it's good that able to cover that OpenAI model part as well. So you could see there are not drastical difference. Either you are using OpenAI GPT model and the Palm 2 model, right? And also there are other models as well, even open source model. So I hope you gain a good understanding about how to develop a RAG pipeline from the scratch, and also bit of context into the vector databases and various techniques, subfields on around the natural language processing. And also latter part, so we developed Streamlit application, which is basically interface into the your GPT or language model application you develop. I hope you all learn and gain some knowledge out of it. And thank you very much for joining with us. So feel free to get in touch with us. So we'll be able to help if you have any questions. I hope you you will be working with this LLM and the RAG pipelines and develop very creative, innovative applications soon, right? Thank you very much.
Okay, yeah. So thank you, Mr. Nisal Miranga and Mr. Ishara Niranjana for providing such an insightful session. So it was 3 hours long, but it was really helpful for everyone. So I'm pretty sure everyone who has joined here has learned a thing or two from this. So I think the speakers have asked for questions, and I believe most of them have been answered. So we can move on to showing our gratitude to the speaker. So our exploration of implementing generative AI models has illuminated an incredible potential for technology and in artificial intelligence. So a special thank you to our speakers, Mr. Nisal Miranga and Mr. Ishara Niranjana, our distinguished speakers, for generously sharing their expertise and insights with us today. So we sincerely appreciate your time and commitment. So, Mr. Nisal Miranga, your expertise and insights have significantly enriched our understanding of implementing generative AI models of practice. So, we extend our sincere appreciation for your invaluable contribution to today's session. Please accept this token of appreciation. Next, a special thank you to Mr. Ishara Niranjana for generously sharing his knowledge and experiences, for providing hands-on and practical guidance, enriching our learning experience, and helping us apply theoretical knowledge in practical settings. So, Mr. Ishara, please accept this token of appreciation. So before we adjourn, let's capture this memorable moment. So to all our participants here, kindly turn on your cameras as we prepare to take a group photo to commemorate this engaging session. So we'll give 2 minutes for everyone to get ready to turn on the cameras and take a group photo. Okay, in 1 more minute, we'll be taking photo. So all those who are comfortable switching on the camera can do so now. If not, we totally understand. Okay, I think we can take the group photo. So 3, 2, 1, and smile. We hope okay, there are still a few more who are opening the cameras. Yeah, I think you can take a few more photos. Okay. Thank you everyone for turning on your camera. So yeah, we actually have an exciting announcement to keep the momentum going. So get ready for the AI Bootcamp Hackathon, which is scheduled for the 10th of December at the IIT School of Computing, starting at 7 a.m. and running until 5 p.m. Lunch will be provided, of course. It's a 4-hour hackathon that promises to be an immersive experience, and we encourage you to start preparing from now on. So here are some key details for you. So we encourage the use of the Palm 2 API for case study implementation. Feel free to also use the open AI APIs, which were mentioned in the session. So, but bearing in mind your token usage costs. You have the flexibility to choose any framework or language stack for your implementation. And we'll provide you with with multiple use cases, and you'll have 30 minutes to choose one. So ensure you have come prepared with the background work from the fourth session, which is this session. So as you'll only be given 4 hours for the implementation. So stay tuned for more details and announcements about the hackathon. We're counting on your enthusiastic participation. So team leaders, grab your phones and scan the QR code given on the slide to access the AI hackathon confirmation form to confirm your team's participation and get set for an exciting challenge. So we'll give you guys some time to scan the QR code and access the form and fill the form. All right. Moving on. So yeah, the link to the Google form is also given in the chat box. So you can either click on that or you can scan the QR code. So next, let's take a moment to express our heartfelt gratitude to those who make this event possible. So big thank you once again to our partners who played a crucial role in support. So our trailblazing partner. Sorry, excuse me, your microphone is unmute. Okay, so once again, a big thank you to our partners. So our trailblazing partner, IFS, our AI expertise partner, Zone 24/7, our mentoring partners, WSO2, 99X, and Nagaro, our industry collaborative partner, Slascom, our ecosystem partners, Virtusa, Trace, and Axeler, our judging partners, LSEC, Surge Global, and Mad Mobile, and our venue partner, the IEEE student branch of IIT. Your support is truly appreciated. So as we wrap up, we will wish you all a delightful evening. Your presence has given this event its vibrancy. So we look forward to seeing each and every one of you in the upcoming hackathon. Have a fantastic day. Bye.